Hi, this is Shebin Sam Abraham of registration number URK18CS277. And today I'm going to explain the 11th experiment of operating system lab, and that is disk scheduling. So the aim of 11th experiment is to perform disk scheduling algorithm that is first come first serve and the shortest seek time for scheduling. So first come first serve and shortest seek time for schedule, that is disk scheduling. Enter the details, enter the variables, like I'll just go into the algorithm. Means it's the simplest of, like, every request gets a fair chance, no indefinite postponement. I mean, like, once we enter a data and we search for that, the first detail is going to get repeat. The first detail comes first, which we enter the first value, that's going to come first. That's first come first serve, and no indefinite postponement. So that means, like, once we enter a value, it never gets lagged, or that value never goes at the end. Which value has been entered the first in the stack, that value gets the chance, a fair chance. So this is a program. I'll just go directly into the execution of my program. Yes, so using so this is done by using a C program, that is hash include stdio.h int main int of q. I'm taking that as q. We are using it over here, not stack, it's q. Enter the first variable. I'm like, it's not a stack, I'm sorry, it's a q. I'm sorry, it was by mistake, it is a q. And then variable n, head variable, and then I, j, k, seek is equal to 0, and max and diff. Float average, we're taking the average variable also. Enter the maximum range of the disk, the size of their queue, and like how many variables it is stored, and the queue, and enter the queue of the disk position to be read. And then we open a for loop over here. Scanf q of I, enter the initial head position, that is scanf ampersand d, I mean, like in a scanf percentage d of ampersand head, that is a head variable. We are going to put head like variable, like what should be the head value. And then q of 0 is equal to head, means in q, which is the first variable, that is the head. That is going to be mentioned as head. Now for, we are opening, so for of I has been opened, or for of j. For j equal to 0, j is less than equal to n, j plus plus, and we are going for diff is equal to abs of q j plus 1 minus q of j. So the next position minus the current position gives a variable that's stored in diff, and then seek plus diff, the seek variable which I'm entering into it, which I'm seeking for the variable, that plus the q the last position minus the first position, I mean the second position minus the first position, that variable, the diff value, gets both added and saved into C. And then the disk can move from percentage that's printf with seek, we're just printing in the variable, and then printf the total seek time, and then average is equal to seek, the seek time divided by the total, I mean by the number of variables I have entered into it, and then the average seek time gets printed over there. So let's just go directly into the program and then we'll read from that. So we'll just run it. I'm taking it as 200. I'm taking the size of q as 8, and then the variables are 98, 183, 37, 122, 14, 124, 65, and 67. And my head variable I'm taking as 53. So it gets calculated over here, and once it gets calculated, it will be shown as, enter my initial head is as 53, and then each disk moves from the top variables. It keeps on moving and checking which has the least variable. It keeps on calculating the difference, the second position minus the first position, the third position minus the second position. So it keeps on like reducing it over there. It gets on subtracting over there. It gets subtracting, and then the total seek time will be given over there as 640. By that is the seek time, and the average time is the seek divided by the number of variables, and then that is total seek time is 640 divided by the number of variables I've taken as 8. So 640 divided by 8 will be 80. 8 into 64, so it will be 80. So average seek time is 80 and total seek time will be 640. So this is how we do C programming using deadlock. Now we are going to directly to C++ programming, and we're going to see over there how this is going to work. So here I'm entering this as, so C++ programming, how this schedule is going to work. So hash include bits, then using namespace std, you int main, int of I, j, k, and m, sum is equal to 0, x, y, h, and then the size of disk, the number of request, and then the enter the request, and then vector int of an of b, and then map int mp for I equal to 0, I is less than n, I plus plus, cn of a of I, and then we are entering the details into the, we are storing the details, and then for I equal to 0, if a of I is greater than n, then error unknown position, return 0, breaks the loop. Enter the head position, and then int of temp is equal to h, temp variable taking it equal to h, and then int of element, push back, it gets pushed up, like it's like same as we are taking the difference, is pushing back. Counting is like if it's 2, push back, it goes to 1, the first variable, and then while count of n, count is equal to 0, while count is less than equal to n, means n when it gets n means like if you're giving the number of elements as 8, so when 0 is less than 8 means it goes for difference, taking difference as 9999, that's taking off large variable. And then we are doing a set of instructions over, set of calculations over here for auto, means it gets automatically established over there, installed over there, and then abs of q first temp is less than the diff variable, diff is 99. If it is less than diff means element is q of first, that's the first variable, and then mp element minus minus, and then it gets pushed back element count plus plus, and then if temp of b of 0, int of head we're taking as 1, for I is less equal to 1, I less than b of size, I plus plus, c out of b I minus 1, and then b of I minus 1 minus b of I is less than 0, c out it gets printed, else if it is or b of I minus 1, b of I gets printed over there, and it gets a new line feed, and sum plus is equal to abs of b of I minus temp, and then 0 of n, total head movements, and then return 0. So here we'll go directly into the program, and then I'll show you from there how it is being done. So enter the size, that is 200. Number of requests I'm taking it as 9. Request is 53, 65, 67, 37, 14, 98, 122, 124, 183. Yes, and the head position is 53. So it gets the head difference variable, it gets subtracting over there. 53 minus 53 is 0, 53 I mean 65 minus 53 is 12. It gets reducing from the top of the head stack, it gets like reducing over there. 67 minus 65, 37 minus 67, and 67 minus 37, 37 minus 14, 14 minus 98, and then it gets 98 minus 122, 122 minus 124, 124 minus 183. The variables get decreasing over there, and then we add up all these variables over here. We get the total head movements as 263. we get it as 263 is the total movements the head has moved. Yes, so these many variables, like these many value, these are the movements that it has done by reducing it, by subtracting it, head differences, adding all the heads, and you'll get the total head movement as 236. So using C program and using C++, we have shown like how much it gets the total head movements. I mean, like, total how much gets variables, like how to find the seek time. C program, we found out how to find the seek time and the average seek time by seek divided by the total number of n. And then here in the C++ program for the same we found out the total head movements by finding the difference of each in the queue, the variables. Second position minus first, third position minus second, fourth position minus third, fifth position minus fourth. So it get subtracted. Final, how much variables are there? It all got added, and total head movement is 236 are the total head movements. So this is how we do the 11th experiment. Yes, this is how we do the 11th experiment, that is disk scheduling. So here ends my 11th experiment. Thank you.